Hey, what's going on? In this video, I'm going to help you decide about different degrees that you could choose if you're interested in technology. So we'll look at computer science versus a career in software development. My name is Shad Sluter, and I am a professor of computer science and software development at Grand Canyon University in Phoenix, Arizona. And so I have kind of an insider's view on how these work and what kind of students work for them. So I'm going to try to help you make a decision on what you should study if you are considering entering into one of these degrees. So don't forget, if you're interested in this kind of information, to subscribe and also check the notifications so that way you can be up to date on when new information is available. So what do you do in these two different degrees? And some similarities. You probably are interested in technology and what do they do for you? So similarities is what we'll start with first, and then we'll talk about some of the differences, and then maybe at the end of the video I will give you my personal opinions. So not everybody would agree with those, so stick around to see what I would think there. So in both of these degrees, you're going to learn a variety of programming languages. They're obviously about computers. You're also going to deploy apps. You're going to use the internet. You probably work with cloud hosting. You're going to create things that are similar. You might be doing websites, computer apps, or mobile apps. And there's some similarities there. You're going to also learn processes to develop software in a proper manner. Now, what is the difference, though? Because you probably came to the video thinking, are they the same? Are they different? Well, let's talk about what maybe would be an emphasis on each of them. So what languages would you probably see if you were in a software development degree? So this is about developing applications, websites, and focus on the customer experience and in client experience with your apps. So you're going to be working with front-end technologies such as HTML and CSS. You're going to work with back-end technologies. You're going to work with databases that connect. So you're going to work with Java, C#, and JavaScript, maybe PHP, maybe a bit of Python, depends on what kind of project you're on. For the back-end, you're going to work with SQL, for sure, and Mongo or something that is NoSQL. So different ways that you can accomplish the same thing. But this is a full stack description, a full stack of a web development toolkit. So that would be a software developer's collection of things. Now, what would be different if you were in computer science? So what kind of languages are computer science people into? So I would say these, like Python, C, C++, assembly. We could probably add Java to it if we wanted to. But these are going to be a little less emphasized on the amount of coding you do, but more of how you would apply these. So if you're a big data analyst type of a person, Python will probably be here. Maybe R. If you're into general coding, C++ is a great tool for object-oriented programming. A little bit crossover here into the engineering world. And then if you're working on hardware and you're developing drivers and firmware and communicating with the bits and bytes and the signals that are running through the wires, you're probably going to be in either C or assembly, or maybe Verilog, or something that would be tied to logic gates. So anyway, computer science and computer programming or computer software development would have slightly different emphasis. So specifically, the front end is going to involve HTML, CSS, and JavaScript. They're web design languages. These are used to make your front end work. Java and C# are both considered back end. They do similar tasks. Java is run and owned by the Oracle Corporation, and C# is Microsoft. But they're both very much the same. Now, there are competitors that could do some of these same things. You want to create a back end for your website. You could write it in Python if you wanted to. You could write it in JavaScript even. You could write it in Golang, which is kind of a new language. You could write it in Ruby. So there's these tools that are maybe less popular, but in our experience, in my experience in job placements for people that are looking here, or at least in the Phoenix area, C# and Java pretty much are a 50-50 balance for enterprise companies that are building software that is on a large scale. Now, JavaScript is not Java. It is a web browsing scripting language. And usually tied with that is one of these frameworks, either React, Vue, or Angular. And these make your JavaScript more professional, you might say, more maintainable, scalable. A lot of the things that make updating a user interface are automatically done for you, and so those are worth learning. You could also run JavaScript on the server if you have Node.js, but that's maybe not what it was designed for originally. We're going to work with developing web apps, and of course you put them on the internet because they're for the web. So AWS and Azure are the two big competitors, and then of course others like Heroku if you have an alternative. Now, what are you going to study in each semester that you do this degree? It's 4 years of work. Are you going to enjoy each semester as it comes? Let's give a look here of what might be ahead. So I said here software engineering courses in the title. Really, software development courses is what I meant to say. So you can see there's a huge emphasis every semester on a programming language. So the entire first column is about languages. So starting off with static websites and HTML. Java 1, Java 2, Java 3. You're going to learn 3 different levels of Java. Then C#, we're going to do the same thing. C# 1, 2, and 3. What else is there for programming? JavaScript and web applications. That's a class about React and Angular. Then we've got some computer science over on the right side, where it's data structures and algorithms and operating systems. Those are overlapping with computer science. There's going to be a class on databases, business planning, cloud computing, and then both degrees, at least at the university that I teach, are going to have you do a senior project. So a semester of planning and a semester of implementation, and you've got yourself a pretty good collection of core classes here. So this isn't the entire curriculum, this isn't the entire course walk, but it gives you what I call the main subject areas. Now, computer science is the next slide here, and you'll see a little difference. First of all, you see lots of different programs. So there's computer science specialties. So if you get a degree in computer science from one university, it might feel different than from another because there's a variety of things you do with these languages. But this is pretty typical, I think. So Java 1 and C++ are the 2 language courses. So you notice right away that we don't spend nearly as much time learning the proper way to code. You just kind of start and then you apply it in different ways. Another difference that you're going to see is that there's a lot of science and math here that are required that are really difficult classes. So this kind of makes the change or makes the decision for some people to say, I'm not going there. For instance, do you want to take physics? Do you want to take calculus? Do you want to take statistics? Do you want to take linear algebra? Those are all pretty, what we call brainy classes. Those are heavily science-based. What else is in here? I know the computer graphics course is related to linear algebra. It's probably related to trigonometry, some calculus. So computer graphics is not simply learning how to use Photoshop. Computer graphics is learning how to draw those 3-dimensional shapes, how to handle making colors and rasterizing different collections of bits. So it's the math of how you would build Photoshop or how you would build a 3D structured program. So there's a lot of theory in this as well. So you can see that you can't just say, I'm going to borrow a library and start using it. That's what a programmer would do. Say, hey, it's already been decided and invented for me. The computer scientist is the person that invents it. So for instance, compiler design. I mean, I use a compiler all the time. I write software. It needs a compiler. But have I ever actually written a compiler? No. Computer science people would. How about the idea of this second from the end? We got data mining, modeling, and simulation, and data analytics. That is a specialty. So if you want to become a data mining specialist, a big data person, that would be kind of a track that you would follow. You can see the last line, we have mobile games, game design, and AI. So if you want to become an emphasis on working with video games. So that kind of gives you an idea that this is a very in-depth, difficult, technical, and less so much about designing software as it is about the algorithms and the way that the computer would think and actually solve these problems. So what's similar between these two? Well, we are writing code, we're solving problems with algorithms, and you would even apply for similar jobs. However, I believe that there are some jobs that you're better suited for with each degree. Let's put the contrast together now. So in computer science, as I mentioned, the emphasis is on theory and algorithms, and math and science, and then also with maybe compilers and things like that. Operating systems. So this is classic computer science curriculum. You'll find this at most large universities. Most everywhere would have had this program in for decades. Now, if you're in software engineering, or what we would call at our university is software development, there's an emphasis on writing code. Writing code and then creating well-designed applications. I'll give you an example of what the difference between those is. So one of the professors of computer science told me, he says, Chad, he says, I know how to write code. I can program in lots of different languages. But that doesn't mean I know how to build an enterprise application with all of the different design parts of it. He said it's similar to the idea that I know how to read and write in English. I can understand it. I can write coherent sentences. But writing a novel would be a bigger challenge. I'm not sure I could do that. And so maybe software development or software engineering is more like, how do you make an app that is scalable, secure, reliable, rather than just understanding the algorithm that's in it. So it's about the software design and the development process. And we also focus in on frameworks. So these are important. Frameworks are because they are the resume items. So if you put yourself down as you can program in Java, that might be okay, but really Java is worthless unless you can apply it somewhere. So if somebody says, I know Java and I can use Java Spring, which is the framework to develop websites, that's much more impressive. Or I can say, I know Java and I use it in Android Studio, so I can develop mobile apps. So frameworks are the way to make your resume stand out. And so the frameworks that we learn in software development include, like I mentioned, Java Spring. And if you're in C#, you're going to learn ASP.NET. .NET Core is the current edition. And if you're into PHP, you're going to learn Laravel. If you're into Python, you're going to learn Django. So these are all different frameworks that make professional quality applications. So let's talk about one side or the other if we were to categorize different kinds of projects. I'll give you some specific examples. So let's start with this one. We've got an app here in front of us. We're designing a mobile app. And you can see we're making wireframes. And we're designing the navigation. So the challenge of this project is software design. So let's put it over on the left side, which is software development or engineering. Here's another challenge. Let's say you are tasked to come up with an improved version of a facial recognition algorithm. The one we have now only works 80% of the time. Make it better. So that would definitely fit in the computer science realm. How do we make machine learning and how do we make algorithms work efficiently? Let's go to this. Let's say we have a challenge. We want to make a front-end interface for our company's assets. We want to have a flexible website that will be scalable for phone, for tablet, and for laptop. So that would definitely say that would fit better with a software development degree. How about this one? If I said, let's make a challenge, that your assignment here is to create a chess game. The chess game will learn how to play chess, and it will improve every game it plays. So that sounds like an artificial intelligence and machine learning exercise. And so that would probably fit in the category of computer science. How about this? We want to have a task where we have all kinds of languages, scripting languages, compiled languages, and we're going to build all these things into one project. That would definitely be in the software development part. Here's another category. In our university, if you're into virtual reality, if you're building things in Unity and you are creating models and simulations and games, that's going to fit in our computer science degree. How about this one? We want to have a responsive design. We want to make sure that our website looks good. We want to make sure that we know how to use CSS properly and that we have layouts that are correct. So both of these degrees would want to know how to do that, but computer programming, computer software development is more likely. How about this? If we're in a project where we're building a car, a self-driving car, and we want to make sure that it has cameras, it can see where it's going, it can learn how to drive, it doesn't crash. That sounds to me like an algorithm problem. That's the computer science side. So you're probably going to work with electrical engineers, or maybe that is an electrical engineer's job, but computer science would be related. Here's another assignment. So now you're tasked with, looks like the logic gates. We're literally getting down to the transistors and the logic of your computer chip. And we've got the clock signal. We're inside the computer. We're working with hardware. So you might be programming this in C, or you might be in Verilog, or an assembly language. But this is definitely going to be the electrical engineer kind of idea, computer engineering, or we'll call it computer science. So what are some of the key words that you're going to want on your resume? So I'll just let you pause the video if you want to look at these in detail. But when students from our program graduate, we want to make sure that these are items that they can talk about in an interview. These are the things that find you an interview. People use, collections of resumes on LinkedIn or something to look for specific technologies. And so these are some of the key terms that you will learn if you're in a software development degree. Just like that, there's going to be some things in computer science that people are looking for. So you're going to have a different kind of a job depending on what your resume looks like. So these are some of the terms that would show up in a computer science degree. Now, I would recommend that you don't just generalize in all of them. There's probably one or two that you really get involved with and specifically an expert at. And that's what gets you distinction between you and all the other candidates for the job. But so here's some ideas for what a computer science person might specialize in. So there are advantages and disadvantages to each side. You can't learn everything, so what are we going to emphasize? So the advantages, I would say, here's where my opinions come in, that in the software engineering or software development world, you're going to find a better resume for your first job. Because most companies are worried about developing applications. So let's pick a company, for example, State Farm. They're a big employer here in Phoenix. Or Carvana, they used car salespeople. Are they interested in developing a mobile app, a web app, and customer service issues, sales? They're going to want you to have all those frameworks. They want you to be able to do really well at designing their front-end app. However, they also might have some kind of a research at the end where they say, we have data mining issues. Albertsons Foods, for example, came to our job fair and they said, we are interested in big data computer science people because we have a lot of data analysis. But anyway, my idea is that software engineering, software development is the classic big company need where you have to have good applications. So you're better aligned here for software development degree if you're into this software development career. And I think this probably fits pretty well. What I wish they had taught me in school, that actually happens here. So some of the people that have graduated have looked as good as a person with 2 or 3 years experience in the job market. Because if you try to fit a computer science person into an application development role, they're going to spend the first 3 months or 6 months or whatever learning the framework that the company uses. So if the framework is ASP.NET in C#, then why not just learn that in school? What are some of the advantages of computer science? So this could also be considered maybe somewhat controversial, but you could demonstrate that it's true. Smarter students. What is a, quote, smarter student? Well, a student that is willing to take physics, calculus, linear algebra, and what was the other? I forget, some other statistics and probability. Those are really tough classes. They are very academically challenging. And students that are able to do that obviously have the ability to learn and to stick to it. How about this? Computer science is a widely recognized historical degree. So in computer programming or software development, I think Grand Canyon University even might be unique in the idea that we have a degree in software development. Most people would take a computer science person and try to retrain them in their first job to become a software developer. So software development is not as widely known. Computer science certainly is. There's a wide use of the term in academics. Also, you would think that a computer scientist is more geared toward work that is a little bit like an electrical engineer. In the example of the self-driving car, you might get a job working on that as a computer science graduate, but you also probably will work right alongside with electrical engineers. And my point is, if you're going to do electrical engineering work, then why not just get a degree in electrical engineering? Well, that's for another video, I guess. From what I've seen, that computer scientists are better programmers than programming in electrical engineering. So the engineers will get mad at me for saying that, but it's true. That's not their specialty. They have other things that they've learned. You can't learn everything. So the point here is you pick one side or the other and you go to where your interests are or to where you think your employer wants you to go. So I hope that helps you. These are ideas for making a decision on what kind of degree might match you better. So there are other options out there. Maybe I'll do some videos on those. But for now, take a look at the channel and please subscribe, and I'll see you soon.